students, Assalamu alaikum. I hope you are fine. We are studying a course Organic Polymer, and the topic which is understudied is a synthetic polymer, and related to synthetic polymer, our today's topic is polyacrylonitrile, and it is said to be PAN, PAN, polyacrylonitrile. Polyacrylonitrile is also known as polyvinyl cyanide. It is a synthetic semi-crystalline organic polymer resin with the linear formula is C3H3N whole N. It is a thermoplastic polymer. The monomer of this polymer is acrylonitrile or vinyl cyanide. It's a monomer. When it will undergo to polymerization and it converted into a polymer named as polyacrylonitrile or polyvinyl cyanide. If we use the term acrylonitrile for the monomer, and we will use polyacrylonitrile for its polymer name. Like if we use the name vinyl cyanide as a monomer and its polymer is said to be polyvinyl cyanide. Both are same things. So students, monomer acrylonitrile can be obtained from acetaldehyde and hydrogen cyanide. Here is the acetaldehyde, CH3CHO. How we can represent? Like here, carbonyl carbon, and one side is CH3 and other side is hydrogen. When it will treated with the hydrogen cyanide HCN, this CN negative charge attack on this carbonyl carbon and this pi bond shifted towards oxygen and negative charge will appear on oxygen. So here is the CN attack, look like this. CN attack on this carbon, pi bond shifted towards here on oxygen as a negative charge, and that negative charge will grab the hydrogen from HCN and convert it into OH. Now students, what will happen next? Look here. This CH3 we can represent like this CH2 and one H appear on above side, as we have to eliminate this H, and this sigma bond will be came between these two carbons and converted into a double bond. Now students, here as a catalyst we will use the H2SO4, and H2SO4, when the negative part of this H2SO4 like HSO4 negative, this HSO4 negative, it will grab the proton, this, and the bond will be shifted between these two carbons and here a double bond appear. This HSO4 negative, when grab this proton and it will restore its position and convert it into H2SO4, while the H part, HSO4 negative and H plus positive part will grab this hydroxyl group and convert it into water like this. Now the product which is formed is said to be vinyl cyanide or acrylonitrile. This carbon where the substituent CN is attached, this is a vinylic carbon, and overall it's said to be the vinyl cyanide and acrylonitrile. First, again I am repeating, when acetaldehyde react with this HCN, it will convert it into 2-hydroxypropane nitrile, and while using the catalyst H2SO4, it will convert it into acrylonitrile and water. So it is our perspective monomer which we have to be required for the preparation of polymer. Now we will move towards the preparation of PAN, polyacrylonitrile. Polyacrylonitrile can be prepared by the polymerizing acrylonitrile by using suspension or solution polymerization techniques. Student, this is an important terms. We have to remember these techniques and it is important for the perspective of MCQs. Generally, polymerization is carried out by free radical polymerization. The question may be asked, which type of polymerization take place for the preparation of PAN? So it may be free radical polymerization. Which type of technique used? It is suspension or solution polymerization techniques. Next, here is the monomer, vinyl cyanide or acrylonitrile. If we take n units of this monomer and it will undergo to free radical polymerization. Students, you are familiar with free radical polymerization and you have now the detailed mechanism in very earlier topic. Now it will undergo to free radical polymerization and it will convert it into a polymer which is a PAN, polyacrylonitrile. Here is in a block a point is mentioned. Anionic polymerization are also used here. Interesting. Earlier we said that free radical polymerization may take place or may carried out, but maybe anionic polymerization are also used, not cationic. Remember it. Now we will move towards its properties. First property is it has a very good resistance to chemicals, heat, and it up to 200 degrees Celsius. It has good mechanical properties. It is soluble in polar solvents, for example, dimethyl formamide, DMF. Polyacrylonitrile behave as both branched and linear polymer. What is the application of polyacrylonitrile? The copolymer of butadiene and acrylonitrile, mean nitrile rubber, has great industrial importance. Second important application is polyacrylonitrile is used to making carbon fiber. Very interesting point. What is carbon fiber? Students, it is interesting to know that about the carbon fiber. What is the main series to prepare carbon fiber? First we will understand its true picture, then we will understand its uses and purpose. Here is the vinyl cyanide or acrylonitrile. When it polymerized and converted into a polymer chain, and this polymer chain we already studied above. As we know that students, carbon and nitrogen, between these two carbon nitrogen a triple bond is exist. And when this polymer will rearrange to cyclize, here this triple bond will convert it into double bond and one single bond will came between these carbon and nitrogen. Here carbon and nitrogen. Here carbon and nitrogen. Look again. Here this monomer undergo to polymerize, free radical polymerization, and it will convert it into PAN, polyacrylonitrile. When this polyacrylonitrile will rearrange to cyclize and it converted into a structure here. A cyclic structure appear. Now this cyclic structure will undergo dehydration. Mean when we will melt it at 600 degrees Celsius or we heat this cyclized structure, cyclized polymer, and it undergo to dehydrate. When mean hydrogen release. When hydrogen release from this carbon and this carbon, a double bond appear here, here, here and here. And now it is a conjugate structure where double, single, double, single. Such type of compounds take place or appear. Student, this is a carbon fiber. It's a carbon fiber. And what is the precursor of this carbon fiber? The precursor of carbon fiber is polyacrylonitrile. And what is the precursor of this polymer? The precursor of polyacrylonitrile is acrylonitrile. Now students, what is the purpose of this carbon fiber? Student, it has a great important property or application. It does not melt even at 1000 degrees Celsius. Notice this block. Even 1000 degrees Celsius, carbon fiber does not melt. They have impact range is greater. Its impact range is greater as comparatively to steel. If we compare carbon fiber with steel, then the range or impact range of carbon fiber is greater than steel. And where it apply, carbon fiber is used in the facial part of rockets. When rockets fly, the facial part of that rocket, which is made up by the carbon fiber, as if we imagine students, a lot of heat or friction present when rocket move on height. That friction and heat will directly attack on the facial of the rocket, and if this carbon fiber not present there, the heat will enter inside the rocket where life does not exist due to high range of temperature. So how the passengers will survive there? The main reason is that the stability or resistivity is a carbon fiber. This carbon fiber will protect the internal area of rocket from heat and from that friction or resistance. So it has a very important application towards the rockets for their manufacturing of the rockets. So students, it is an important information as I have shared. So just imagine it and try to understand. I hope you enjoy this lecture. Kindly share your feedback. Thank you.